Hello student, I am Jyoti Patil, teacher at Atul Tutorials. We are going to study today chapter Work and Energy. This chapter is included in the syllabus of 9th as well as in 10th standard. Therefore, it is beneficial for both these standards. We are going to hold this session in bilingual mode, Hindi as well as in English. We will cover this entire chapter in 3 sessions. इस particular session में we are going to discuss the basic concept related to the work, that is scientific work and types of work. So let's start. First topic is scientific work. हम हमारी डे टू डे लाइफ में बहुत सारे ऐसे टास्क परफॉर्म करते हैं, लाइक सम हाउसहोल्ड टास्क, we play some outdoor games, we do some homework, and we call all these tasks as work in our day to day life. But क्या हम इन सारे वर्क को साइंटिफिक वर्क कह सकते हैं? Can we refer them as scientific work? And if it is not, then what is scientific work? Let's take an example. This is first picture where this girl is applying some force to lifting this chair. And in this second picture, this boy is applying force on this ball, and by the application of the force, this ball get displaced. So in दो पिक्चर में हम साइंटिफिक वर्क किसे कह सकते हैं? This second picture is referred as scientific work. Why? Because work is said to be done only when the force acts on an object and displaces it or makes it move. That means these two conditions are very required for considering any task as work done. First one is force should be applied, and second one, by the application of this force, the object should get displaced. In the first example, this girl is applying force, but there is no displacement. There is no displacement. So therefore, this first task we cannot term as scientific work. But in second example, force is also there. This boy is applying force on this ball, and due to this force, this ball get displaced. So both the conditions are there. Force is also there and displacement is also there. We use S to indicate displacement. Also we can use D. S or D, both the letters are used to indicate displacement. As we have discussed, we can call any task as work done, as scientific work done. Two conditions should be satisfied. First one is the application of force, and second one, there should be displacement. Here some more examples we will study. In this first example, this boy is applying force to this box, but due to this opposite force which is applied by this man, due to this opposite force, this box is not able to displace, not able to displace. So force यहाँ पर है, but displacement it not, displacement is not there, therefore we cannot call is this task as scientific work, हम इसे scientific work नहीं कह सकते. But in second example, if we see, in second example, this boy is moving along the direction of, this boy is displacing or moving along the direction of applied force. So here force is also there and displacement is also there. So we can term this task as scientific work. In this third example, this girl is applying force and this appliances is displacing in this direction. So force is there and displacement is also there. So we can call this third task also as scientific work. But there is a difference between this second and third task. क्या difference है ये? In second task, this boy is displacing in the direction of the force. And if the force and displacement both are in same direction, suppose let's consider this box, and if you are applying force in this direction and if the box is also displacing along the same direction of the force, then work done can be calculated by using the force F into S, that is force into displacement. यहाँ पर हमने मल्टीप्लिकेशन का ही साइन क्यों लिया है? मतलब हमने F प्लस S नहीं लिया, F माइनस S नहीं लिया, F डिवाइडेड बाय S नहीं लिया, बिकॉज यहाँ पर हमने टू कंडीशंस आर वेरी इंपॉर्टेंट. यहाँ पर हमने देखा फोर्स एंड द डिस्प्लेसमेंट, टू कंडीशंस आर वेरी इंपॉर्टेंट. बट इफ we took this F into S and if displacement is 0, work done is equal to F plus अगर S अगर हमने लिया and if displacement is 0, then work done is equal to force होगा. Same things will happen with this also and this also. So work done is equal to force सिर्फ नहीं हो सकता, ठीक है. अदरवाइज ये फर्स्ट टास्क भी साइंटिफिक वर्क होता क्योंकि यहाँ पर फोर्स प्रेजेंट है, डिस्प्लेसमेंट नहीं है. So this is not possible. We should consider force as well as displacement. Therefore, हमने addition नहीं ली है, subtraction नहीं ली है, division नहीं ली है. We have considered only multiplication. So this is work is equal to force into displacement. This particular formula we are going to use to calculate work done when the force is in the direction of displacement, like in the second example. But in this example, this boy is applying force this boy is applying force in this direction and displacement is in this direction. So force is also there and displacement is also there. But यहाँ पर इन दोनों में एंगल है. The force is applied in this direction and the displacement is in this direction. So there is an angle between force and displacement. And this angle is denoted by letter theta, like this. So if there is an angle between force and displacement, we can calculate work done by using this formula. That is, work done is equal to F into S or D, both the letters you can use, F into S into cos theta. So this formula is used when there is an angle between force and the displacement. Let's solve a numerical for both the cases. First one for when the force and displacement is in same direction, and for second case when there is an angle between force and displacement. When there is an angle between force and the displacement. This is an example for the first case. Here we have applied force of 7 Newton on this box, and due to this force this box get displaces of 8 meter displacement. So here force and displacement both are in same direction. This displacement is in line with this force. So we are going to use the formula work done is equal to force into displacement. Here it is given. Work done is equal to force into displacement. Force value is given 7 Newton. Displacement is 8 meter. So 7 into 8 will get 56 joule. Joule is the unit for work done. So 7 into 8, 56 joule will be the work done for this first example. This example is for a second case when force and displacement, this is displacement and this is force. If there is an angle between the force and the displacement. Suppose this boy is applying force of 16 Newton in this particular direction and the displacement is in this direction. Let's consider this displacement as 10 meter. Then when there is an angle between force and displacement, we use formula to calculate work done is F into S into cos theta. Here value for the force is 16 Newton into value for the displacement is 10 meter into cos the angle between force and displacement is 28 degree. By calculating this, we will get 16 into 10 into value for the cos 28 is 0.88. We will get answer as 140.8. Approximately, we can write it as 141 joule. Work done is equal to 141 joule. Next topic is types of work. Types of work. There are three types of work. One is positive work, one is negative work, and zero work. Let's see. In positive work, force and displacement both are in same direction. That means if we consider in terms of angle, there is a no angle between force and the displacement. Both are in same line. So therefore, the angle between force and displacement, force and displacement is theta is equal to 0 degree. So If we calculate work done in terms of this formula, F into S into cos theta, that means F into S into cos 0, because the angle between the force and displacement is 0, because both are in same line. Therefore, work done is equal to F into S into cos 0 is equal to 1. So therefore, the calculation for the work done is equal to F into S, that means positive. So therefore, this work is known as positive work when the force and displacement both are in same direction. Second case, when work is negative, when there is a displacement, direction for the force and the direction for the displacement is exactly opposite. Suppose if this is a ball, if it is moving in upward direction, suppose if you apply force to this ball, and due to this force this ball is moving in upward direction, this is the direction for the displacement. But according to the ground surface, this is the direction for the gravitational force in downward direction, and this ball exactly moving opposite direction to the gravitational force to the gravitational force. This is the direction for the displacement of the ball, this is the direction for the gravitational force, which is exactly opposite to each other. So if we are if calculation of the angle between displacement and the force, this angle is 180 degree, because both are exactly opposite to the each other. And if we calculate work done for this case, as work done is equal to F into S into cos theta, will get F into S into cos 180, and value for the cos 180 is -1, and therefore work done will be negative. So this particular work is termed as negative work when the direction between force and displacement is exactly opposite. Then the third type is zero work. Zero work means when the direction of displacement of an object is perpendicular to the applied force, 90 degree to the applied force. Let's consider, suppose if an object is moving in a circular path, suppose if an object is moving in a circular path, this particular object is moving in a circular path. The force applied on this object is from the center. This is the direction for the force. But the object which is moving in a circular path is in the direction to the tangential to the circle. So this is the direction for the displacement of the object which is moving in circular path. So there is an angle between force and displacement is 90 degree, and if we calculate work done for this case, work done is equal to F into S into cos theta, which is equal to F into S into cos 90. F into S into value for the cos 90 is 0, and by multiplying this we'll get work is equal to 0. Therefore, this particular work is termed as zero work. So these are the three types of work. First one is positive, second one is negative, and in third one is the zero work. Next topic is SI unit of work. SI unit of work. Calculating SI unit of work, which is very simple. We know the formula for work, that is work is equal to force into displacement. Work is equal to F into S. And if we know the SI unit of force and distance or displacement, we can easily calculate the SI unit of work. That is, SI unit of force is Newton, SI unit of distance or displacement is meter. Then by combining these two units, we will get the SI unit of work as Newton into meter. Newton meter. Work done is calculated in Newton and meter. But the SI unit of work can be also termed as 1 joule or joule, which is exactly equal to the Newton meter, because the study related to the work is done by this joule scientist. Therefore, by honoring this scientist, the SI unit of joule, SI unit of work is also referred as joule. In this session, we have covered scientific work, types of work, SI unit of work. In next session, we will continue with the energy part.